saving his mother from hours of drudgery, he'd also sent an inspiring message to students and coders around the world that if AI can solve problems in cucumber farming, it can solve problems just about anywhere. That message is now spreading quickly. Doctors are now using AI to diagnose and treat cancer. Electrical companies use AI to improve power generating efficiency. Investors use it to manage financial risk. Oil companies use it to improve safety on deep-sea rigs. Law enforcement agencies use it to hunt terrorists. Scientists use it to make new discoveries in astronomy and physics and neuroscience. Companies, researchers, and hobbyists everywhere are using AI in thousands of different ways, whether to sniff for gas leaks, mine iron, predict disease outbreaks, save honeybees from extinction, or quantify gender bias in Hollywood films. And this is just the beginning. We see the real story of AI as the story of this diffusion. From a handful of core math concepts stretching back decades, or even centuries, to the supercomputers and talking, thinking, cucumber sorting machines of today, to the new and ubiquitous digital wonders of tomorrow. Our goal in this book is to tell you that story. It is partly a story of technology, but it's mainly a story of ideas and of the people behind those ideas. People from a much earlier age, people who were just keeping their heads down and solving their own problems involving math and data, and who had no clue about the role their solutions would come to play in inventing the modern world. By the end of that story, you'll understand what AI is, where it came from, how it works, and why it matters in your life. What does AI really mean? When you hear AI, don't think of a droid, think of an algorithm. An algorithm is a set of step-by-step instructions so explicit that even something as literal-minded as a computer can follow them. On its own, an algorithm is no smarter than a power drill. It just does one thing very well, like sorting a list of numbers or searching the web for pictures of cute animals. But if you chain lots of algorithms together in a clever way, you can produce AI, a domain-specific illusion of intelligent behavior. For example, take a digital assistant like Google Home, to which you might pose a question like, "Where can I find the best breakfast tacos in Austin?" This query sets off a chain reaction of algorithms. One algorithm converts the raw sound wave into a digital signal. Another algorithm translates that digital signal into a string of English phonemes or perceptually distinct sounds, breakfast tacos. The next algorithm segments these phonemes into words, breakfast tacos. Those words are sent to a search engine, itself a huge pipeline of algorithms that process the queries and sends back an answer. Another algorithm formats the response into a coherent English sentence. A final algorithm verbalizes that sentence in a non-robotic sounding way. The best breakfast tacos in Austin are at Julio's on Duval Street. Would you like directions? And that's AI. Pretty much every AI system, whether it's a self-driving car, an automatic cucumber sorter, or a piece of software that monitors your credit account for fraud, follows this same pipeline of algorithms template. The pipeline takes in data from some specific domain, performs a chain of calculations, and outputs a prediction or a decision. There are two distinguishing features of the algorithms used in AI. First, these algorithms typically deal with probabilities rather than certainties. An algorithm in AI, for example, won't say outright that some credit card transaction is fraudulent. Instead, it will say that the probability of fraud is 92%, say, or whatever it thinks given the data. Second, there's the question of how these algorithms know what instructions to follow. In traditional algorithms, like the kind that run websites or word processors, these instructions are fixed ahead of time by a programmer. In AI, however, these instructions are learned by the algorithm itself directly from training data. Nobody tells an AI algorithm how to classify credit card transactions as fraudulent or not. Instead, the algorithm sees lots of examples from each category, fraudulent, not fraudulent, and it finds the patterns that distinguish one from the other. In AI, the role of the programmer isn't to tell the algorithm what to do, it's to tell the algorithm how to train itself what to do, using data and the rules of probability. How did we get here? Modern AI systems, like a self-driving